Yes, good morning. Hello, here in Germany it's currently 12 o'clock. So in your country it's already afternoon. So hello from Germany. Um, I hope you can see my slides. Is everything working?
Yeah, it is working.
Okay, thank you very much. So also congratulations from my side to this very interesting study. I read it, were way interested, and thank you very much to invite me to this event and also to share some insights or some thoughts from my point of sight. So I'm from the German Wuppertal Institute for Climate, Environment and Energy. So we are the largest sustainability think tank in Germany, and there I'm with a division of future energy and industry systems. So it's more the systems analytical department of our research institute. And I'd like to draw your attention to one special challenge of energy modeling, and that is that we usually have one target optimization in energy models. So I will give you some thoughts on combining energy model with multicriteria assessment instead of using only one target. So I go to the next slide. Yes, as you know, there are lots of different energy scenarios. You already showed that you have assessed way much of them for India and also for other countries. And we also discussed this, and the keynote speaker also pointed out that it's quite difficult for the policy decision to make policy decisions and for the political advisors to show in which direction the energy policy should go. And the problem, I think, is that we have lots of technology oriented mapping of the energy system. So usually we have a techno-economic evaluation as a basis. For example, cost potential curves which serve as a basis for the energy models. And we have usually one target function. This is minimizing the economic cost, so the macroeconomic cost of a country or system. And then we have side effects. Usually we have the side effect or side condition of reducing greenhouse gas emissions by 2030, as you showed in most of your studies, or by 2050. And this is usually are the basic targets of energy models. But what's missing is that other challenges cannot be mapped directly with energy models. So the water consumption are usually not considered as you showed in your study. Usually no energy model does consider the water consumption or the consumption of mineral resources. That does not play a role so far. Different social acceptance of technologies is not considered, or structural fit of new technologies to existing energy systems. So the system's compatibility is not considered, or lifestyle changes, for example. If you speak on sufficiency, how many cars do you need, or how large houses do you need, is not considered. So it's a methodological challenge to include different goals in the optimization. So in principle, it would be a multi-goal optimization. How could solve this? I collected some different ideas, possible solutions. So the first one, the easiest one, is the ex post evaluation of cost optimizing energy scenarios. So as you did in your study, and I think you showed how difficult it is and how large differences appear if you consider all the different scenarios. So you consider each individual side impact, water consumption, resource consumption, job effects, and so on. Or you could do a two-target optimization. So in reality, it's not an optimization because you can only optimize one target. But you could consider two ones in parallel. So you could look at greenhouse gas reduction versus resource consumption, or greenhouse gas reduction versus use of water. So you could optimize one target, for example, greenhouse gas reduction, and then adjust the other one. So find a local optimum, or vice versa. You optimize a system regarding the water consumption, and then you find the best solution regarding the greenhouse gas reduction. So it's quite difficult, but you could do this. Or you could use systems dynamics methodology, working with causal loop diagrams. On the right-hand side, you see one on the IT sector in Germany, where some scientists made an attempt to find all the different cause-effect relationships between the most interesting factors. And there's also resource consumption and energy consumptions, but lots of different factors. So you could try to optimize the whole system, change one factor, change the other parameter, and so on, play around with such a system. Or another idea, and that I will show in the third slide, in the final slide, is that you don't use different models with only optimizing one single factor, but maybe, and that's an idea, to combine multi-criteria analysis on MCA with energy modeling. And advanced MCA, also multi-criteria analysis, goes in different dimensions. So you assess technologies, or you assess energy systems with different dimensions. For example, the technology dimension, the politics, social dimension, the ecology, and the economy dimension. And then you have different targets in each of the dimension, and you have several sub-targets. And then you can combine and assess the different criteria to the technologies, and you get a ranking. For example, in this case, you find the best technology which has the most of these impact points, and you have the worst technology with only a few impact points. So this is an advanced methodology done over the last 2, 3, 4 decades. There are lots of different sub methodologies within the multi-criteria analysis. And the idea is to combine advanced MCA with advanced development of energy models. So I think this is a large research field. There are some examples. I collected some examples from Germany. For example, there's an ongoing dissertation on such a topic, multi-criteria analysis for building and assessing sustainable scenario pathways. So this is from the Helmholtz Research School. Helmholtz is a large research association in Germany. Or you can more look on societal scenarios and combine this with energy models. There's already a published article and work on this. Or you can use agent-based modeling in a model within model approach, so that you include quite different model, in this case on agent-based, so on societal actors, and combine this with simulation and energy systems analysis, also already published. But I think these are single examples, and it's a huge challenge to do this in this basic research, I think, to include such multi-criteria assessment into energy models. But if this would work, then finally you would not have all the work as you did in your study, that you have to ex post evaluate all the different scenarios, but we could include it into the energy modeling. And so I think it's quite interesting to go on this exercise together with modelers, together with technology advisors, technology assessment colleagues, and maybe it could be also an interesting task for your group, your institute, and other Indian institutes together, maybe with us or with DLR or other institutions and research institutions in Germany. So that was my final slide, and thank you very much for your attention from Germany.